All right, good morning. So, announcement as usual, let's take a look. Your written test number 1 will be tomorrow, Wednesday, during your scheduled lab session. Please make sure you only go to your enrolled session. Otherwise, there'll be no seat. We are fully packed for the sections, okay? And for yesterday's review session, if you want to review the material, iPad notes, code example, and also the recording, it's on the lecture site. And your lab number 1 is due this Friday. I know you're busy preparing and studying for your written test 1, but don't forget, your programming test 1 is actually next week, right? So you may also want to make progress on lab number 1 as well. And I still got my office hour today and Thursday, the usual time. So if you need any assistance, don't be hesitant to reach out. And for your markup programming test from last Friday, so if you want to try it again, I also got grading tests released on the on the E-class. You can also import the grading test and maybe assess more thoroughly about your development Java classes. I'll release the solution a little bit later this week. I think it's most important for you to try first. Do not just wait for me for the solution. Guys, are we ready to have the class? You know, to really respect everybody, I would say please minimize talking. That'll be much appreciated. Okay? Thank you. And for those of you who took the practice test last Friday, I'll try to also give you some feedback pretty soon. I'm just confirming some final details with the TA. So I'll let you know very soon. All right, so that's about the announcement. And then there was another announcement just clarifying some confusion maybe about the iClicker percentage rate, but you can read the announcement. I thought that should be quite straightforward. Let's do a recap. All right. It is important to move on with exceptions today. And hopefully we can finish the discussion. That'll be very, very intended. Okay, let's take a look. All right, so last time, let's see what we did, right? That's about a written test review. But I just want to point out something very quickly. So we talked about caller callee already, right? So you should now be familiar with the terminology. And then we got call stack. So given several pieces of code, and you should really figure out the caller callee and then build a call stack. That's also something we went over in detail in class. And call stack. This diagram here is so important, and you really want to review it. And yesterday in the review session, I also revisited this call stack over here and make some more observation. I think today I will also start with some more observation about a call stack. It's maybe a new idea to many of you, so I think it's important to get it right the first time. Right, we'll talk about the different execution flow, normal versus not normal, depending on if exception occur. And we talk about version number 1, right? For to handle or not to handle. And I'm going to recap very soon, and then we should do the other 2 versions to really make the picture complete. And then we'll do 2 more examples about exceptions. That should be good enough for the lecture purpose. And then I'll do a little bit of comparison with the exception handling versus no exception handling, in which case we do some console tester, like a system.out.print line. Why would that be bad? That's something we'll do at the end for this lecture. All right, so let's now move on to some stuff here. All right, so this will be like a review very quickly. So we talk about the catch or specify requirements. It is important for you to know whenever if some exception occur, you have to distinguish between normal versus abnormal. Right? Abnormal when the exception actually occurred, in which case the top of the call stack is going to throw the exception and somehow you'll be propagated until certain points. That's something I'll summarize in the next page. Normal will be no exception occurring, in which case just from top to bottom to execute your lines of code. Right, so try and catch syntax we introduced to you. And now let's say this. If I have a method call over here, so they may or may not throw some exception, right? And we got 2 cases over here. So let me highlight in green to talk about normal. And another one in red, that'll be abnormal, right? The same method call. It may or may not throw the exception, right? In the normal case where it does not, let's say this one here, pardon. Let me just adjust the, all right. Sorry. What I want to do is do this one here. Okay, good. Sorry about that. All right, so for this one here, the exception did not occur. Okay, the exception not occur. In which case, how is the execution flow going to go like? After this, we're going to execute the remaining of the try block over here. So that's why I'm highlighting green here. And then the whole catch block is going to be bypassed. We don't execute it anymore. Right? So this one here is completely bypassed. So that's the normal flow. All right? You can think about normal flow would be basically just execute the entire try block. Right? The method call that may throw the exception, but it did not, and then execute the rest of the try block. What about abnormal? So let's say we try to execute this line of method call, and then that one there, this time, maybe the input is such that we do have the exception occurring. So exception here occurred. So exception occurred. Right? In this case, we're going to be disrupted, go all the way to the catch block. Right? That's how the execution flow is going to go like. So we're going to go for catch block. It's going to catch the relevant exception, and then you're going to execute the entire catch block. All right? And then it is important to know that the rest of the try block after the method call, it will be bypassed. And there's one more block which I missed in both cases. You can see the catch block over here and the catch block over here. We got some more lines of code beyond the catch block, right? In both cases, they will be executed. Because try and catch, think about the like units. Once it is done, for the rest of the your code, you still need to execute them. Right? So it's going to be this one here, and also this one here. Okay, recap. In a normal case, you got to execute the method call. Exception did not occur. Go for the rest of the try block, bypass the catch, and execute the remaining part. In the case where exception actually occur, execute the method call, and then we got to bypass the rest of the try block. Go on to the catch. Once the catch is done, also execute the rest of the code outside the try and catch block. Okay, so these are the two cases. All right, any question about this? Anyone? It is important to really get this idea straight, right? Because the example that we talk about, they all follow this principle over here. Any questions? Yes?
So if exception occurs, that means the program will crash?
Crash may not be the right word to say. If the exception occurred, that means somewhere in the call stack, which I'm going to show in the next page, the exception occurred. That means some caller has to handle it. So at this point, the normal flow is going to be disrupted. But how exactly it is disrupted, it depends how the exception handler, when exactly it will occur. So I wouldn't say crash. Mm-hmm. Yeah, just how error occur. Yeah. All right, let's now do another page over here. So this, I'm just trying to make it very precise for you to see exactly what's going to happen. But I'm going to use symbols, a little bit more mathematical to generalize what's happening over here. But it's not too bad. Don't be too terrified by symbols over here. It's just making things very precise. Let's now look at the call stack over here. Okay, we got basically class number 1 all the way to class n. So we got n method calls in the call stack, right, to begin with. So we got n method call. And then correspondingly, you can see method 1, method 2, all the way to method n. All right, so we got n methods in the call stack. And let's now try to answer each of these questions over here to help us understand more generally how the catch or specified requirement should go. Okay? And this is also something I discussed in yesterday's review session. Now I'm just trying to explain that a little more systematically. Okay? But that's, repetition is nice. Okay, let's start with the first question. Origin of the exception typically should be from the top of the stack. All right? So this will be the origin of the exception. All right? The origin of exception. So I'm going to say C1.M1. That's easy to see. All right? Question 2 and question 3, we should look at them together. Which are the methods that would be subject to the catch or specify requirements, meaning that the method wouldn't compile if they didn't either throws the exception or do the try and catch block, right? Either option there. The other question would be, which method would be free from the catch or specify requirements? Right? So these are the two questions we want to answer. And you got so many methods here in general. So where do you see the cutting point? There should be some cutting point somewhere in the middle. For example, the cutting point could be here, let's say. This might be the cutting point to say all the methods above should be subject to, and all the methods underneath should be free from, right? So what will be so special about this cutting point over here? Given that you already studied for written test 1, can somebody tell me? Let me rephrase the question, repeat the question. For every particular runtime execution for exception, in the call stack you have, you should be able to find a cutting point over here to say, this point here, above, all the callees would be subject to the try or catch, the catch or specify requirements. All the callers underneath would not be subject to the requirements. So what's really so special about this cutting point? Anybody? It catches? Yes, it will catch an exception. That's correct, but let me make it more complete. It will be the very first method, counting from the top of the stack, that will catch the exception. That is so important, right? And that's something I will emphasize to you again in the Eclipse today. Okay, so guys, you want to really be very clear about this conceptual picture here. So this one here, let's say just I, right? So this will be the first method choosing to catch it, to catch the exception. All of the methods above, they will choose to specify it. All these methods over here, they choose to specify it. Everything. All of them will choose to specify. And most importantly, from here downwards over here, they will be free from. Because the exception has been handled already at this cutting point. All right, so it's going to be free from the catch or specify requirements. All right, it is so important to understand the cutting point here. All right, over here. And let me say a little bit more. Here, choose to specify. Okay, let me choose this. Let me say here. And of course, they will be subject to the catch or specify requirements. Let's now use this diagram here to answer the questions to the left. Okay? What are the methods subject to? So it will be from C1.M1 all the way to C, well, right before that, right? It will be CI-1 dot N I-1. Doesn't include CI.M1 because that's the very first one that will choose to catch it. All right? And methods free from the catch or specify requirements, it would be everything starting from this point over here, I+1. All right? You'll be CI+1 dot N I+1 all the way to the last one. All right? Think about it. I'm hoping that this will help. Let's talk about two extreme cases. Okay? Extreme case number 1. What about the exception that's actually thrown from here is handled earliest? Typically, we don't handle that right away. Let's keep that assumption. Okay? Where would be the first method that can handle that earliest? Agree? That could be here. Right away by its caller. So in this way, it will be C2.M2. And let's go to the other extreme. Let's say all the subsequent callers, they are simply lazy. They never choose to handle it. In that case, we got the whole stack over here. Apart from the origin, all the other methods over here, they choose to specify it only, which means the exception, once it's occurred, it will be propagated all the way to the console, which I'll show to you as well today. All right? So that will be extreme case number 2. So that will be from all methods choose to specify, meaning that the exception may just be thrown to the console. All right? Any question about this conceptual sketch?
Why is the CIMI not scaled to CS1?
Okay, yeah, strictly speaking, it should be, yes. I like the precision you have. I agree. That's absolutely correct. So we should be including that one too. Yes, I agree. All right. So all these methods were subject to the requirements, but the last one over here chose to catch it. That's why we'll break here. All right. Good. I like the correction. Yes?
What was the correction?
The correction is we included this subject here, this category here, including this method as well. So that'll be the very first method that's subject to it, but it chose to catch it rather than specify it. Right? All right. Okay. All right. Any question about this? All right. If no, let's now move on. So let's now continue with our Eclipse demo about the different version. I got 2 more versions to say. For version number 1, we discussed that thoroughly already last Thursday. You can review it, but let me just remind you very quickly. For version number 1, we basically got a very simple call stack only with 3 methods here. So the exception was thrown over here, propagated by default into here, and then here this method is where we chose to catch it. So that's the extreme case number 1. We chose to catch it right away. That means this method here is no longer be subject to the catch or specify requirements. If you got any doubts, you can revisit the lecture from last time. And important to note over here, this one here no longer subject to. Not subject to the catch or specify requirements because its callee already handled that. All right, that's version number 1. And let's now try to build on top another 2 versions to see the different flavor of handling. And before I go back to the Eclipse, let's plan quickly. What I'm going to do is exception will still be thrown from here. When it's propagated over to here, different from version 1. We are now also going to specify it, which means it will be propagated further to here. And now, what about this method here? You can choose to either catch or specify. Let's say you will choose to catch it, right? This is the second version. So that means all the methods now will be subject to the catch or specify requirements, especially for this one here. This one here, why would it be subject to the requirements? It's because its callee over here right now chose to specify it. So we have to handle it somehow. All right, let's now try to go back to Eclipse. And last time, we talked about version number 1. Right? I'm going to reuse most of the code. I'm just going to show you exactly what you have to change. And I will encourage you to really do this exercise as well on your own. All right, so I'm just going to copy this package here and then paste it. And let me call that version 2. All right? And then we're just going to make some very slight modification. For class A, we don't need to change anything because it's going to throw the exception. That one's OK. But what we need to do is this one here. This is the change. The change will be rather than catching it, we're going to specify it, right? So this is going to be the specify option. And then we'll see what the consequence is. One thing to note. Once we say we want to specify this, that means this will be subject to the catch or specify requirements. This will be subject to the catch or specify requirement. And we're going to see that by using the compiler, right? Just notice these 2 points I'm going to make, all right? Let's go back here. And then let's see. So let's go to class B, the caller of A.ma. From version number 1, it catches that. But now we're going to specify it. I'm going to just get rid of the try and catch block. We don't need it. Just make it very simple here. And also this. As soon as I've done this, of course, not surprising, it's complaining that this MA might throw some exception. I didn't handle that. Let's now choose the other option. Rather than catching, I'm going to specify it. Throws negative value exception. Okay, I may have to import it properly. Give me just one moment. Let me do it again. Okay, I need to handle that. Oh, sorry, I put it in the wrong place, I guess. Never put besides the class throws. I guess maybe that's what I did. Okay, let me try again. Throws negative value exception. Okay, that's exactly what I did. Never put a throws beside the class, but after the method. All right, I'm going to make sure I import the right version here. All right. Are we good? So now in class B, and now I do have the specify option, but I'm creating another problem, which will be the bottom of the stack, which is tester. And that one should not be surprising. It's complaining that I'm calling MB. If you look at the here, I'm calling the MB method, but that was specified, so I got to handle that, right? So that's why initially it doesn't compile. Now, what do I need to choose? Let's choose the try and catch. So what I will do is I'm going to say try these 2 method call. I'll put that in a moment. And then I'm going to catch that particular negative value exception. Negative value exception. You can do something about it in the catch block. I'll leave that to you. And then I'm going to put it here. As soon as this is done, everything is fixed. That's version number 2. Kind of follow what's going on? All right. That's good. And let's move on to version number 3. For version number 3, let's see this. That may be something that will be very interesting for you to see. Exception is thrown from here, and by default, propagate it, specify it. Now, this guy here also specify it. Now, this guy also specify it. That means when the exception occur, it will be propagated all the way to the console. That's something we would like to see. Let's experiment that. Let me go back there. Let's now try to make a copy of version 2 and then paste it. And we got version 3. All right, let me go there. And then go to class B. Choose to specify so we don't touch it. Let's go to the tester. And now this time we choose to also specify it. Okay. Let me first of all get rid of the catch block. Try and catch block. Of course, as soon as I'm done that, it's going to complain. Oops, sorry. Do it again. Sorry. There we go. Yeah, and try catch was specified. Let's now specify it, which I can say, besides the method, throws negative value exception. Everything compiles, right? But you will rarely see the method itself is going to specify. But I'm just showing to you it's possible, right? And I'm actually going to execute this guy here, right? Minus 46 is expected to trigger some exception from here. In which case, you'll be propagated all the way to the console. All right, let's see what's going to happen. If I execute the tester from version 3, okay, there we go. Sorry, just a little bit slow. There we go. You see that in the console there? So the exception has been thrown to the console, to the user. It's usually a no-no. You don't really want the user to be bothered by the exception itself. All right? All right, any question about the three versions? Go ahead.
We have these specific exceptions, and then it still throws exception.
Say that again. Which line are you talking about?
When you say throws in line type,
Yeah.
you have to be so specific, or there is an exception reserved.
I would say you want to be, the question was, when I say throws negative value exception over here, do I need to be so specific about this particular exception? It depends. I would say, in general, you want to be as specific as possible, because when user reads about the API of your method, they can be aware what kind of exception that will be thrown. If you simply say, let's say, exception, which is a class in Java, it's not very helping. I'm just telling you the method may go wrong, so don't rely on that. It's a very irresponsible attitude, right, from the main method, so you don't want to do that. But once we talk about, maybe after the reading week, I can briefly mention later, for exception, they're also structured in an inheritance hierarchy, in which case sometimes mentioning some class may represent many other possibilities at the same time. But let's not be confused by that for now. At this moment, you want to be as specific as possible. If you got more than one exception possible to be thrown from the method, you will say exception 1, comma, exception 2, comma, and etc. Okay. All right, so that's about the third version here. And then, okay, that's good. Oh, I definitely, yeah, that's good. Okay, I just want to make sure, yeah. And in this third version here, let's make a final remark. In this case, all the three methods are subject to, right? None of them is free from that, because none of them choose to handle. All subject to the catch or specify requirements. That's about this example here. Right? I'm going to make the source code available to you, play with them, put a breakpoint debugger, do the kind of exercises I showed to you last Thursday. I think that's going to help. Right? Not just for written test 1, I mean for general Java knowledge. That's important. Anything you want me to clarify further? Go ahead. Okay, so the question was, is it possible to get away from catch with specified requirement? If you don't use exception, there will be no such requirement, which I will show maybe at the end. For this particular lecture, you can simply use console messages by saying system.out.println. There's some error occurring. But I'm going to show you that that one is unacceptable. Okay, I'm going to show you. But let me just go back here. So your classmate was asking, what about we just don't want to be bothered by all this catch with specified business? If you don't really have this very initial line over here to say the method may throw some exception, you just don't use the exception mechanism, then we don't really need to be bothered by these all these issues that we talk about in the call stack, in the catch with specified requirements. However, I'm going to show you maybe in about 20 minutes or so, if you try to just use a system.out.println, print some error message to say you got some negative value to the console, it's not going to be as ideal as the exception, but we're going to see that. Okay? Okay, we're going to see more examples about try and catch or exception handling in a more general sense. All right, we cover version number 1, version number 2, version number 3. They're all done. And let's now look at 2 more examples. They're kind of straightforward. So for these 2, I also made the source code available to you. You can try them out, but I'm only going to do that on the paper just to for illustration, so you get a big idea. The first one is simple. Let's say we have a class called circle, and it has a method called setRadius. And of course, the radius, if that's negative, then there should be some exception, invalid radius exception. Otherwise, if the radius is larger than or equal to 0, then we can set the radius to be r. And then we got some excessive method here, which will calculate the area of the circle, right? Apparently, if the user simply gives you some double number or integer number, or double here, if they give you something that's non-negative, that'll be good. No exception should be thrown. If they give you something that's negative, you should really expect the exception to be thrown, right? Let's now take a look at the the structure over here. Right? I already explained the circle. And also, once you put this line here, we explain how you can create the exception class almost automatically in Eclipse. Right? That's something I'll leave you to do. Let's look at the tester over here. Right? We're going to look at, again, 2 different execution flow to get an idea. Let's now take a look here. So we got circle calculator 1. And then inside the main method, we're going to make a call. So circle calculator 1 dot main. So that'll be the entry point. And then we created a circle objects, and then we try to call the method set radius. And we're going to put some value over here. I'll do that in a moment. We got different possibilities. So that'll be circle dot set radius. So very simple call stack, only 2 methods over here. Right? The next example will be slightly more complicated, but one thing at a time. So we're going to say, after you have set a radius, we're going to actually calculate, after this, we're going to calculate the area and then assign that to area, and then simply print out the area. In case the exception occur, we're just going to print out the exception itself, which is going to give you some detail. You can try it out. In Java, if you say, I want to print out the exception objects over here, it's going to give you some details of it. You can try it out on Eclipse. So that's the structure of the code. And we want to try 2 different test cases. Case number 1, valid radius. Case number 2, invalid radius. Right? Case number 1. Let's try 10. All right? If I have 10 over here, and for each case, let's be very specific about which lines is going to be executed. Right? It is important. So we're going to create the circle objects over here. And then we're going to go into the try block, number 2. And then we're going to set a radius. Right? I'm going to branch out to that set radius. So for set radius, we're going to check the if condition. In this case, R would be just 10. Oh, beg your pardon. R would be 10 in this case, right? 10 less than 0, false. So we're going to go to the else part, which is number 5. In this case, we're going to set the radius to be R. Right? So now the radius will be set to 10. And then when we come back to this method here, right, we're going to resume. Right? We talk about how you can suspend the call and then resume. Right? I'm just skipping the details. That's something we discussed thoroughly last time. And the get area is going to get according to the radius is equal to 10. Calculate the area, and then we're going to go here. Oh, sorry. The number was not exactly continuous, wasn't it? Let me do it again. So here we got number 5, right? So now we should continue. So we got number 6, number 7. And this is going to be calculated where R is equal to 10. And we're going to bypass basically the catch block because no exception is expected. That's case number 1. Very precise about which line should be executed. Any question here? All right. Case number 2. Let's say we want to pass -5. All right. So we want to set the radius to be -5. Let's see exactly what lines will be executed. This line still, right? Create a radius, create a circle objects. We're still going to try the try block, number 2. And then we're still going to call the methods. But now it's going to pass -5, right? And then we're going to go into the set radius method there. So this will be number 4. And then it will be -5. -5 less than 0, true, right? So we're going to throw that exception, number 5, over here, right? So now this line here is going to be bypassed. We don't execute it anymore. So what would be 6? 6 would be, which would be 6? We're talking about this method call here. Because exception will be thrown, so the rest is going to be bypassed. So 6 is going to be, we go to the catch block. And then, sorry, I can write a little bit better. And then go here, number 7. Right, you can see side by side how the two cases are going to execute the code differently. They cover different lines of code. All right, that's what I want to talk about for this circled example. Any questions? What you should do, just before I answer, what you should do is go to the source code I made available to you, put a breakpoint in the beginning, and verify each case if those are the lines that will be executed. All right, to convince yourself. Question?
So can we throw the exception in the method there? So don't we go to the exception and then come back to the execution?
Say it again. Which line I talk about? This one here?
Yeah. So after this, don't we go to the exception that we specified on top?
Oh, over here? Yeah, well, of course, this one here, I agree. This one here, we have to create that particular new exception object. So implicitly, we have to go there first, but I'm just not talking about that one. That one a little bit too much. Yeah. Of course, in the test or in the exam, if I also include these lines over here, of course, you have to include them for creating the exception. But let's now not worry about it. So here, conceptually, we're only doing one thing in this line. Create the exception object and throw it. Just make it simpler, conceptually. All right, if everything's good, let's do the second example. Slightly more complicated, slightly. Oh, before that, I would like you to take a look at this second variant to the circle calculator. I'm just going to let you read the code and study the code yourself. I want to highlight to you what's interesting about this example here. So we got circle class the same as before, nothing changed. And I got circle calculator number 2. The difference is, in circle calculator number 1, I can only set the radius only one time and see the flow, and set it the second time and see the flow. But I can now put everything into the context of a loop. Okay? I'm using a Boolean variable to control the entrance and exit from the loop. Right? That's basically the extension I made. And exactly 1, 2, 3, and 4. 4 lines I have added. All right? I'm just going to explain some insight into using this Boolean variable, and your exercise will be trying to figure out the execution flow for these two values. Apparently, this one here is going to trigger some exception. And this one here is not going to trigger an exception. But let me just say a little bit more about the Boolean structure itself. So we have a while loop over here, and then we want to say, whatever the user, well, we use a scanner, right? Scanner here, which we did in lab 0, part 1 or part 2, right? So we got a scanner here, which is going to read some input from the user. And we're going to create a circle. And then we're going to use whatever the user enters as a radius, which can be positive or negative, right? So think about the R here is going to be the R over here. And the R comes from the user input. And we want to say the following. This is important, okay? When we try to make this particular method call, right? And let's now make some annotation. This method call, we know that it may throw negative invalid radius exception. Let me be precise. Invalid radius exception. It may, right? If there's negative radius. I have a question for you. If I'm able to go from this line to this line over here, does it mean the exception occurred or did not occur? Did not occur, right? So being able to reach this line over here, that means the exception did not occur, meaning that the input was valid. In that case, I will set this Boolean value to be true. All right? Let me make an annotation here. So here the insight will be the exception did not occur. And we are ready to exit from the loop. Because as soon as we set the Boolean flag over here to be true, it's going to make the negation of it false. So we can exit from the while loop. So the idea will be we keep asking the user to give us some radius. If they keep giving us some negative value, we just keep asking them until they give us a positive one. Okay? So this one here is keep prompting for a non-negative radius until the first one that's non-negative, and then we are good. All right, another one to really notice is, which will be, give me one moment. There we go. If we reach this line here, right? This line. Again, let's go back to this method call. If the exception did not occur, we're going to go to this line. If the exception occur, we're going to bypass the rest and go to the catch block, right? And reaching this line. So reaching this line means the exception did not occur. Beg pardon, exception occurred. In which case, we're going to prompt the user again. Because the exception did occur, the value for this Boolean flag remains false. In which case, not false is going to make sure we still stay in the while loop until the user gives us some positive number. So we can exit from the loop. Right? This structure here is not complicated, but it does review very nicely how you can manipulate Boolean variable. I just mentioned to you about the essence for this example, right? What you should do is look at the structure more closely and try out the two test cases I include over here. Right? This can also sharpen your code tracing ability. Right? I would suggest you do that. All right? If you haven't followed this example completely, that's okay. You just need to dive into detail. But I already mentioned to you the trickiest detail in the example exercise. All right. Any question about this? Okay, if you guys are good, why don't we do one more? Yes? Mm-hmm. Okay, let's go back to here. Let's see what's going to happen. Let's say we try to read the input from the user. Let's say R happen to be negative. Let's say -2. Okay? And then we're going to create a circle objects, do the try block no matter what. And then when we call this one here with -2, we know that some exception will be triggered from the circle class. So now in this case, we bypass the rest. So we go directly from after this into the catch block. And then here we simply say, try again. You haven't entered the right value for the input, right? And notice that when we get to here, we don't really reassign this Boolean variable to be true. That means we still want to stay in the loop. Okay, that's something you want to see, exactly how this is laid out. Okay, yeah. All right, let's now move on. One more example, which is slightly more complicated, but not too bad. So this example here is about a bank. Okay, bank example here. Okay, so we got 3 classes. Okay, oh, how about this? Let me do one by one. And we also got a call stack. Let me show you the logic over here. So we start with something called bank application. And then inside, we got a main method. So this should be at the bottom of the stack. So bank application dot main method. All right. And then we're going to make a method call somewhere about the bank. So we got bank application, we got bank, and also we got account. 3 classes. So this is where we're going to call. So here you can see we got a bank declaration. And also this will be where we're going to make a call, right? So bank.add account. So this is where we have. Oh, beg your pardon. Let me say it again. You got a bank object here, B, and then we might need to add account into a bank, right? And every account has some ID, for example, 23. This is not a good practice because I'm not using static variable, but that's okay, just for illustration. And in the try block, I try to call b.withdraw. So this is the method to note, withdraw. I'm saying that I want to go to account with ID 23, and then I want to withdraw this particular amount. And the amount comes back from the user. You can see I'm using scanner again. All right? So the second call would be the bank dot withdraw. I'll say W. All right? And let's now go to bank dot withdraw. So bank dot withdraw method over here. Now it will be the caller. What method is a call? So it's going to call a method from the account class. And you can see we got account over here. By the way, we have an array. Accounts is an array, and also we got an integer counter, right? That's something you're pretty familiar already. And we are saying that we're going to search for a particular ID that we want to withdraw some money from. And then we're going to have a loop to search for that particular account. And once we have found the ID we're looking for, we're going to call the withdraw method. All right? So the withdraw is going to be here, right? That's the method call. And one thing to note, you can see accounts I is basically just an account. That one should be obvious, but just to remind. All right, so we got withdraw. So we got account dot withdraw. Notice that there are two withdrawal methods. Under the bank, we have the withdraw method. Under the account, we also got a withdraw method. All right? And inside the withdraw, inside the account class and withdraw method here, we are checking to see over here. Let's say I want to withdraw a certain amount. What should be the condition for which I should really throw in an exception? If the amount is less than 0, I cannot say I want to withdraw minus 1 million. Right? I cannot. Also, I cannot try to withdraw something that's more than my balance. Right? So these are or. Either one is going to trigger some exception. Right? I can throw some new exception. Right? So it is important, number one, to understand how I build this call stack from the code structure over here. Right? Everything here. And I think callie, we don't need to worry. That's something we already know once we see the call stack. I'm just going to trace very quickly together with you. What if the user enters, let's say, minus 5 million I want to withdraw? Apparently, that should not be allowed, right? So now how are things are going to execute? Let's see. The idea would be we're going to go for this call in this order, and somehow this method here is going to throw the exception to say this is invalid. And then it's going to somehow throw the exception, and then we see how to try and catch what specified requirement is going to proceed. That's something we'd like to see. Let's now try that. So we're going to try this input value here very quickly. All right. So let's now assume the user enters minus 5 million. All right. And then we are withdrawing over here. We're now withdrawing minus 5 million. All right, so we used to be here. So now we are calling the withdrawal method. All right, and when we go to the withdrawal method over here, we're now, let's say once we found the particular account in the array, right? We're going to withdraw minus 5 million. Okay, and then that one there is going to make sure we call the withdrawal method in the account class. So we go to this method here. And minus 5 million less than 0 will be true. And true is going to make the OR operator true no matter what. So this is going to trigger that exception. All right? So that means that exception is going to be thrown from here. It's called invalid transaction exception. Invalid transaction exception thrown. All right? And now we're going to, by default, propagate it into its caller because we got the throws option, right? The specify option, right? This is specify. And what about its caller? Does its caller specify or catch? Specify, because you see that here. Right? That's also specified. All right? Hopefully you're still following, right? And that one also specifies, so we propagate it into the bank application. Now, for the bank application, did we specify or catch? Catch, right? Because you do see that the try and catch, right? That will be the catch option. So that means it will be handled right here rather than being thrown to the console like in version number 3. All right, so that's a bank example, right? Now you just got a little bit more caller-callee involved. But I think after that generalization we studied in the beginning of today's lecture, now this should be no challenge conceptually. But you just need to dive into details for each example, okay? Any question about this? Okay, hopefully you guys are still fine. Why don't we, I think we got, I want to do 2 more examples, and then I will see how the time goes. Why don't we take a very short break, and by taking attendance, let's do that now, and then we'll do 2 more examples. Okay, how about that? Right, a few more things to say about the exceptions. Not very long. Let me start with some additional example, but they kind of just show you what if you got more than one exception expecting from the method call. How can you handle them? Pretty straightforward. Guys, please. All right, thank you. All right, so now we talk about circles before the break, and also we talk about the banks, right? Please also review the slides and really dive into the detail of the code. All right, let's now take a look at the next one. Oh, sorry, not this one. That's the bank, which we also talk about. All right. And then let's see the next example here. Almost there. Okay, more example. Now, the first one. Let me show you directly. Let's say if you got multiple exceptions that might be thrown in a single catch block, in a single try block, what should you do? Let's now take a look. I'm just reusing the example. Let's say we got a big, let me start logically. Let's say we are calling the 2 methods that we have seen before the break. So we got a withdraw method from the bank, which we know might throw. We know that this may throw the invalid transaction exception. May throw invalid transaction exception. We got another method call. Okay, let's say after withdraw, we want to set a radius of some circle, let's say. In that case, this may throw a different type of exception. That'll be, I believe, something like negative radius exception, right? Different kinds of exception. In that way, in general, you want to handle different kinds of exception separately, okay? Each separate exception type should really deserve a separate catch block. So the syntax goes like this. You got a try block here, single one, that will be the try block. And you may have as many catch block as you like. Each catch block is going to specify a particular exception, all right? This will be one kind, which will be negative radius exception. And this will be another kind, which will be invalid transaction exception over here, right? So basically, we're saying that, let's say, here. This withdrawal over here may throw some invalid transaction exception. In that case, it will bypass the rest. And then it may be caught into this particular, oh, you know what? Let me be a little bit more matching on the color. So this one here may throw the invalid transaction exception. It may be caught by this particular catch block, right? It may be, if it happened. Similarly, this one here, set radius, may throw negative value exception. It might be caught into this one here, if it occurred. All right? Let's run one example together, just one. Why don't I do test case number 1? Test case number 2 will be for your exercise. Let's say we try test case number 1. All right? The amount will be 5 million. Let's say we want to withdraw minus 5. Oh, let me use a different color. How about, let's say, this one here. Let's say the amount we want to withdraw is minus 5 million, which is invalid, of course. And the radius is actually valid, let's say 23. All right, let's try that, right? Let's number the line. We're going to go through some decoration, number 1, number 2. And we're going to go into the try block. And we're going to create the bank objects as an account and also do some deposit. That's all fine. And then once we get to line number 7, right? Now, since we got an invalid amount to withdraw, some exception will be expected, right? After this, the rest of the try block is going to be bypassed. That means we're going to go to the catch block. But which catch block should we go to? You should go to the one that matches the potential exception, which would be invalid transaction exception, right? So this part will be bypassed. This will also be bypassed, so we go to here. So it will be number 8, number 9. Yeah, let me just write it a bit more visible. Number 8 will be the catch block, number 9, and also number 10. Right? So that'll be the execution flow. Your exercise will be to figure out the execution flow for test case number 2, in which case calling the withdrawal on 100 is fine. But making the second method call minus 5 for the set radius is going to trigger some different type of exception. How should the execution flow go like? Right? That should be also straightforward to follow. And how do you find the solution? Put this into Eclipse and let Eclipse tell you. Or you can come to my office hour. We can discuss. All right, so this one here will be exercise for you. Exercise. All right, any question about this syntax here? I'm just trying to show you for a single try block, you may have multiple catch block that follow. But you cannot have multiple try block. They don't work together. Question? No, we wouldn't actually. Because in this case, in the first case, because we already got some invalid value here already. So the flow will be already disrupted all the way to this catch. So the rest is not going to be executed. Yeah. On the other hand, if you try the second test case over here, because if we try 100 here, let's sketch. If you try 100 here, that one is going to be fine. And then we move on to the circle, and when we get to the set radius, now minus 5. In that way, minus 5 is going to trigger some exception. That means the remaining part will be bypassed. And then which catch block do we go to? This one here, right? Yeah. Good. All right, that's the first one. And the second one is very interesting, also very practical. Let me present to you the problem. Yes, now take a look. All right, that's the one we just talked about. Okay, second one. This comes from the Java API. If you go to the integer class, capital I, not int, right? Capital I integer class. There is a method there called parseInt, meaning that if you give a string parameter or string arguments, for example, I put in quote 23, it's going to give back to me integer value 23. Yep, okay. That's you can read the API. And I might have, yeah, exactly, some example here. It's a static method, so meaning that you can just use a class name, right? Integer.parseInt, if I give in quote 23, it's going to return 23. But if I say something in the quote that cannot be really translated into a valid integer, it's going to give me some exception, this particular type. Number format exception. Right? Pretty straightforward, right? How the method should be used. And now, I want you to think about what you can try to write. I'll give you 1 minute to think about. We want to have a fragment of Java code that somehow is going to prompt the user to enter a string, right? You can say scanner and the read line. And they can enter whatever they like. They can enter maybe 23 from the console, which will be treated as a 23 in string, or they can enter something that just cannot be turned into number, either way. And then if the user input is not a valid integer, for example, this guy here, we want to prompt it to enter again. Otherwise, we can actually turn that input into a number. And this example here has a similar logic as the circle calculator number 2 that we spoke about before the break. So when you study, you can study these two examples together. All right? Take 1 minute just to see how the method is supposed to work and think about how you may solve this problem conceptually very quickly. And then I'll show you the solution. A hint for you. In order to do this kind of code, you have to be very clear about the distinction between normal flow versus abnormal flow. And this pattern here will carry on when we talk about the next lecture about the JUnit testing. Right? We will talk about something like that too. All right, let's now look at the solution quickly. We still have a while loop over here. So let me highlight the one that's really similar to what we had before in the circle calculator 2. This one here, and then we got this one here, and then, yeah. So the yellow highlights pretty much correspond to that particular circle calculator 2 example. What I want you to look at is we are calling this method here. Look at this line here. All right? So this line here may or may not throw the number format exception. It may. All right? If it does, it's going to disrupt the execution flow. If it does not throw, it's going to continue. Right? So what you want to look at is there are several possibilities. So when we execute the code, it's going to be number 1, number 2, number 3, number 4, number 5, number 6, right? And also number 7. This will be common for both normal and abnormal. Let's say if we enter something abnormal. Let's say we enter 23, right? It's like a quote. All right? Let's say user input over here, let's say it is 23. We know that it's going to trigger the number format exception, meaning that we're going to bypass this line, right? It follows that line. And then we're going to go to the catch block, which will be number 8 and then number 9. And this is going to prompt the user to enter again. Okay? That's the case where the input cannot be turned into a number. What about the second case? Let's say 23 here. We still go up to line number 7, the same, but now the user enters something like a 23 in quote. It's a string. That can be turned into a number indeed. So what's going to happen is, because this is not going to throw any exception, so this one here does not trigger. Does not trigger the number format exception, whereas this first one here will trigger. This one trigger the number format exception. All right? And what's going to happen if it does trigger? Oh, sorry, if it does not trigger. 23 does not trigger, so that means after this line here, we'll just go to number 8 in green. After that, we bypass the entire catch block and move on. All right, so again, I'm putting the two flows side by side so you will see. All right? You can see for step number 8, between the normal versus abnormal. But up to step number 7, they share the same because we haven't got a method call just yet. Okay. Yeah, learn about this example is very practical if you want to turn a string into a number, which may or may not fail. Any question here? Okay, that's good. All right, so I think that'll be the last example for the exceptions. Yeah, I think we got about 10 minutes. I'd like to do at least one more thing, which will nicely conclude the exceptions lecture. So now we learned about exactly how the exception mechanism will work in Java. Let's now go back to the very beginning. why do we need exceptions in the first place, as opposed to system.out.println line? Right? It's a valid question here, and it's worth our attention to conclude. Let's now take a look. And let's now go back to our circle and bank example, which we already learned today, right? And the thing I'm going to do is like this. Okay, let me remind you, we got circle and we got circle calculator. All right, so we got circle calculator. That's the caller, and then we got a main method, right? Just to remind you very quickly. So we got circle calculator dot main. And then we got the callee circle and then set radius, which refers to the circle set radius method over here, right? So we got circle dot set radius, right? Call stack. And very important to note. Now we're trying to explain why the system.out.println line is supposed to throw new exception, right? We're comparing these two solutions. If you look at this guy here, right? You can think about this is a bad alternative to throwing an exception. Number one, can you please note this is the change we have made, only one line. Instead of saying throw new negative radius exception, we are now printing out some new line to this console. All right? Now we want to know why this will be bad, really. You can also look at the slides for detail, but the essence for the answer would be, if you only want to print out something to the console, the staff force this call stack over here to be subject to the catch or specify requirements. Not anymore, because there's no exception here, number one. No catch or specify requirements enforced anymore, because we are not throwing any new exception. This is the number one point you want to notice to begin with. No. Number two, let's go back to where the caller is. Okay, let's take a look at this line. All right? And here I'm passing some invalid value already, -10. For us, conceptually, we are thinking the good practice. If I'm passing some negative value here, which should be invalid, we should trigger some error. Agree? In the case of the exception, if we are now in line number 4, where should we go after line number 4? Well, somehow line number 4, the flow should be disrupted, right? Because we know exception occur. But now in this case, there's no more exception here. So what we should know is, over here, no exception thrown. Only a message printed to the console. That means the rest of the code will still be executed. Despite error. All right? And that one is actually going to still calculate the area even though you specify -10. That's bad. So this really tells us exactly why we will prefer exceptions to console messages. Because whenever you got a method call that might trigger the error, having some exception thrown is going to force the execution flow to be disrupted right away, and you have to deal with it. As opposed to, if you got console messages over here being printed, it does not force such a disruption. Let me do a final demo, and then I will highlight some exercise you can do for the second example for the bank. Okay, that should be good. So how do you look at this for yourself? If you go to another source folder, which I also made available to you, let me close the other example there. Okay, let me just clear this. Clear. All right, so now if you see the packages, there is one called circle without the exception. With exceptions are the ones that we talked about before the break. And without the exception is using the console messages. Let's take a look. And then I'll show you some run. So now in the circle class, you can see rather than throwing the exception, we simply print out something. All right? And then we got a circle calculator over here. And that one there is simply going to read some input from the user. Right? Let's now try. I'm just going to put a breakpoint over here. Oh, how about this? I'm going to put the breakpoint in line number 13. It's after we have read the input from the user. Okay, let's have maybe a few runs. Let me launch the debugger. And it's going to prompt me for the circle. Okay, enter a radius first. Okay, let's say -10. That should really trigger some error, but we don't have exceptions in this case. And then enter, and then I'm going to switch to the debugger right now. Okay. So now we are pausing at line number 13. Okay, line number 13. You can see under variables, the radius r is -10, right? So this should really trigger some error. I'm going to do step into in the next round. Let's look at this round first to look at this level. Because we know there's no exception. So the flow is not going to be disrupted even though error occur, right? So now if I say step over, which line should I go to? 21. Agree? Because there's no try and catch block even needed. So now if I say step over, I'm going to go to circle with radius something -10. This line doesn't make any sense because those two lines are supposed to be for calculating the valid input. But now there's no disruption, so they are still executed. That's wrong. And then if I go on, and they simply give us some nonsense output here. So this example here really shows that if you have any error, rather than throwing an exception, which will disrupt the execution flow, if you only do system the other print line, it's not going to do anything that's going to force the caller to do something special to handle the error. That's really what you want to know. All right? Let me do one more. One more round. And then I'll give you some quick exercise to try, and then we should be good. Let me launch the debugger once more. Okay, let's say -10. Okay, again, we're here. Let's now step into. If I step into, so now we are in the set radius, right? -10 apparently is less than 0. If I step over, now it's system the other print line, rather than throw new exception. If I try that, it's simply just going to execute as normal without signaling any disruption of the flow, right? That's the shortage for the console messages as opposed to exception. All right, so any question about this for the circle, right? What you should do, two things. If you go back to the slides, you want to review starting from, let me tell you the slide number. You want to go from slide number 5, and starting from there, you want to review the console messages shortage, for these two examples, circles and bank. And then give me 30 more seconds, and then I'll be done. And for the bank example over here, just the same structure as before. So what you really want to do is try to trace the code, except that now we got system the other print line, the error, as opposed to exception handling. Now you want to see exactly how the execution flow is going to go like if you got some invalid input, like a -5 million, as we said. All right, so we're done with the exceptions. We'll start with a new topic on Thursday. Thank you.